How do I find the duplicates in a list and create another list with them? How do I find the duplicates in a list of integers and create another list of the duplicates?
To remove duplicates, use set A. To print duplicates, something like Note that counter is not particularly efficient, timings, and probably overkill here. Set will perform better. This code computes a list of unique elements in the source order. Or, more concisely, I don't recommend the latter style, because it is not obvious what notseen.addX is doing. The setAdd method always returns none, hence the need for not. To compute the list of duplicated elements without libraries. Or, more concisely, if list elements are not hashable, you cannot use set/dicts and have to resort to a quadratic time solution, compare each with each. For example,
A very simple solution, but with complexity ONN.
You don't need the count, just whether or not the item was seen before. Adapted that answer to this problem. Just in case speed matters, here are some timings. Here are the results. Well done at John LaRue. Interestingly, besides the timings itself, also the ranking slightly changes when PyPy is used. Most interestingly, the counter-based approach benefits hugely from PyPy's optimizations, whereas the method caching approach I have suggested seems to have almost no effect. Apparently this effect is related to the duplicatedness of the input data. I have set L equals random.randrange 1,000,000 for I and range 10,000, and got these results.
You can use iteration_utilities.duplicates. Or if you only want one of each duplicate, this can be combined with iteration_utilities.unique_everseen. It can also handle unhashable elements, however at the cost of performance. That's something that only a few of the other approaches here can handle. Benchmarks. I did a quick benchmark containing most, but not all, of the approaches mentioned here. The first benchmark included only a small range of list lengths because some approaches have ON2 behavior. In the graphs the y-axis represents the time, so a lower value means better. It's also plotted log-log so the wide range of values can be visualized better. Removing the ON2 approaches, I did another benchmark up to 500,000 elements in a list. As you can see, the iteration_utilities.duplicates approach is faster than any of the other approaches, and even chaining unique_ever_seen duplicates ... was faster or equally fast than the other approaches. One additional interesting thing to note here is that the pandas approaches are very slow for small lists but can easily compete for longer lists. However, as these benchmarks show, most of the approaches perform roughly equally, so it doesn't matter much which one is used, except for the three that had ON2 runtime. Benchmark 1. Benchmark 2. Disclaimer. 1. This is from a third-party library I have written, iteration_utilities.
25 to 26 classic configuration.